Good morning, students. Today we are going to discuss about fluids. In physics, a fluid is a substance that continually deforms or flows under an applied stress or external force. Fluids are a phase of matter and it includes liquids, gases and plasmas. Before going to the topic, we will discuss with activity. Stand on loose sand. Your feet go deep into the sand. Now lie down on the sand. What happens? You will find that your body will not go that deep into the sand. Why? In the above activity, the force exerted on the sand is weight of your body which is the same. This force acting perpendicular to the surface is called thrust. When you stand on loose sand, the force is acting on an area equal to the area of your feet. When you lie down, the same force acts on an area of your whole body which is larger than the area of your feet. Therefore, the effect of thrust depends on the area on which it acts. The effect of thrust on sand is larger while standing than while lying. The force per unit area acting on an object concerned is called pressure. Thus, we can say thrust on an unit area is pressure. What is the formula for the pressure we have? Pressure is equal to thrust divided by area of contact or force divided by area of contact. For the same given force, if the area is large, pressure is low and vice versa. This is shown in the picture. When the area is large, the pressure is less. When the area is small, the pressure is more. This only I told you. In SI units, the unit of thrust is Newton. The unit of pressure is Newton per square meter or Newton meter power minus 2. In the honor of the great French scientist Pascal, 1 Newton per square meter is called as 1 Pascal. It's in short form we can denote as PA. Pascal is the unit of pressure. For honoring French scientist Blaise Pascal, we kept the unit of pressure is Pascal. Pressure in fluids. All the flowing substances, both liquids and gases, are called fluids. Like solids, fluids also have weight and therefore exert pressure. When filled in a container, the pressure of the fluid is exerted in all directions and at all points of the fluid. Since the molecules of a fluid are in constant, rapid motion, particles are likely to move equally in any direction. Particles will keep on moving from one place to another place inside the container. Therefore, the pressure exerted by the fluid acts on an object from all directions. It is given in the picture. Pressure in fluids is calculated by the formula which is equal to total force exerted by the fluid divided by area over which the force is exerted, which is equal to, already we have discussed, which is a common formula for the pressure. Pressure is equal to force divided by area. Pressure due to liquids. The force exerted due to the pressure of a liquid on a body submerged in it and on the walls of the container is always perpendicular to the surface. When an air filled balloon is immersed inside the water in a vessel, it immediately comes up and floats on water. This shows that water, which is liquid in the container, exerts pressure in the upward direction, which is shown on the picture. Look at the picture. One object kept inside the water, which arrow mark, which means force exerted in all the direction. Similarly, liquid pressure acts in lateral sides also. When a bottle having water is pierced on the sides, we can see water coming out with a speed as equal. This is because liquid exerts lateral pressure on the walls of the container.
Good morning, my dear students. In the previous class, we have learnt valence electrons. Today, we learn valency of elements. We know atoms combining together to form a molecule. Valence electrons are involving in the bond formation. So, what is valence electron? Electrons present in the outermost orbit. So, that valence electrons only involving in the bond formation. So, let us see valency. What is valency? The combining capacity of the atoms to form molecules is defined as valency. So, what is valency? The combining capacity of the atoms to form molecules is defined as valency. In the previous class, we studied valence electron. And students, what is valence electron? Number of electrons in the outermost orbit is called valence electron. If number of valence electron is less than or equal to 4, means valency is equal to that valence electron. That means valence electron 1 means valency also 1. Valence electron 2 means valency is 2. 3 electron means valency is 3. 4 valence electron means valency is 4, like that. If number of valence electrons greater than 4 means valency is determined by subtracting the number of outermost shell electrons from 8, because we know a completely filled orbit means outer orbit having 8 electrons. So, we have to subtract from 8. So, already I told valence electrons less than 4 or equal to 4 means valency also same. So, valence electron 1 means what is the valency? 1. 2, valency 2. Valence electron 3, valency 3. Valence electron 4 means valency 4. Valence electron 5 means we have to subtract from 8. So, 8 minus 5 is equal to 3. So, what is the valency? 3. And valence electron 6 means what is the valency? 2. 8 minus 6. Valence electron 7 means valency is 1. 8 minus 7. Valence electron 8 means what is the valency? 0. That is 8 minus 8 is equal to 0. Elements which have valence electrons 1 or 2 or 3 except hydrogen are metals. Elements with 4, 5, 6 or 7 electrons in their valence shell are non-metals. We see one example in sodium. What is the atomic number of sodium? 11. So, electron distribution 2, 8, 1. So how many valence electron present in sodium? 1. So what is the valency? 1. So sodium is a metal. Next, magnesium. Atomic number of magnesium is 12. Electron distribution 2, 8, 2. How many electrons present in the outermost orbit? 2. So that is the valence electron. So what is the valency? 2. Because we know valence electron less than 4 or equal to 4 means valency also same. See another one, aluminium. In aluminium there are 3 valence electrons are present. So valency is 3. We know aluminium also a metal. So elements which have valence electrons 1 or 2 or 3 except hydrogen are metals. Next, in carbon, number of electrons in the outermost orbit is 4. That is, the valence electrons are 4. So valency is 4. So carbon is a non-metal. In nitrogen, number of electrons in the outermost orbit is 5. So valence electrons 5. So what is the valency? 8 minus 5. Because we know valence electrons is more than 4 means we have to subtract from 8. So 8 minus 5 is equal to 3. So what is the valency for nitrogen? 3. So we know nitrogen is a non-metal. In oxygen, number of valence electrons 6. So valency is 8 minus 6 is equal to 2. Oxygen is a non-metal. We know number of electrons in the valence electron is 5, 6, 7 means that is a non-metal. In fluorine, number of valence electron is 7. Valency 8 minus 7 is equal to 1. Fluorine also a non-metal. So elements with 4, 5, 6 or 7 electrons in their valence shell are called non-metals. See, neon is a noble gas. All the noble gases having completely filled orbit. That means outer orbit having 8 electrons. So the valency is 0. 8 minus 8, 0. Next, we find the valency of magnesium and sulfur. What is the symbol for magnesium? Mg. And what is the atomic number of magnesium? 12. Electronic configuration of magnesium is 2, 8, 2. So, outer orbit having how many electron? 2. So, valence electron is equal to 2. So, what is the valency? 2. And what is the symbol for sulfur? S. Atomic number of sulfur is 16. Electronic configuration of sulfur is 2, 8, 6. So, valence electron 6. Valency is 8 minus 6. Because we know more than 4 means we have to subtract from 8. So, valency is 2. So, students, today we have learnt valency. Valency defines the combining capacity of an atom. And valency tells us how many electrons does an atom need to lose, gain or share to attain the stability to form compound. All the noble gases have stable electronic configuration. For example, helium. Helium atomic number 2. So first shell, maximum 2 electrons only present. So that is a completely filled shell. Because it having only one shell, that shell also completely filled shell. And neon, argon. These are the examples for noble gases. So students, I hope you understood valency. Next, one small concept, quantum numbers. These are the numbers which designate and distinguish various atomic orbitals and electrons present in an atom are called quantum numbers. There are 4 quantum numbers: principal quantum number, angular momentum quantum number, magnetic quantum number, spin quantum number. And students, just you learn this 4 types, that name only, because in your higher classes only you will study this 4 quantum numbers detailing. Just you learn this 4 names only. Okay, that is enough. So students, today we discussed valency of an element. In the next class, we will study about laws of chemical combination. Thank you.